Hi guys, thank you for those of you doing your homework and classwork early. It's really helpful for me because then I can actually see what people are making mistakes on. This question is very similar to a question that all 6 students who attempted it got wrong, so I just want to go over this. This is something related to what we learned the last couple weeks, but we actually never graphed logs because it wasn't in the textbook, so I didn't put it in our notes. You will be doing this in pre-calculus next year, so I just wanted to go over this one more time so then you guys are a little bit ahead of the game. So we're graphing y equals 4 log base 5 of 3 minus x. So what we're going to think about is our prerequisite knowledge. So what stuff have we already learned about that would help us graph this? What we've already learned is about logs in any base. So for example, log base 5 of 5, we should know 5 to the first is 5, so we know that already equals 1. We could say log base 5 of 25 is 2 because 5 squared is 25. Log base, the lone part exponent. So 5 squared equals the lone part 25. We can also say log base 5 of 125 is 3. We can go backwards actually and say that log base 5 of, we would say 1 because 5 to the 0 is 1. And we could go back one more time if we really wanted to log base 5 of 1/5. 5 to the what is 1/5? -1. So this is the information that you would already need to know in order to graph this without using an exponential function and then switching it into logarithmic form. So here we are with all of this information. So what we're trying to figure out is this right here should probably equal 1/5, 1, 5, 25, or 125 to make our lives easier. So if I look at those things, I'm going to try this out. So 3 minus x could equal 1/5. 3 minus x could equal 1. 3 minus x could equal 5. 3 minus x could equal 25. Or 3 minus x could equal 125. The easiest way to do this is subtract by 3 and then divide by negative. So turn all your answers to a negative. So if I subtract by 3 for the easiest one, I would get -2. Divide by negative is +2. Subtract 3 is 2. And then divide by negative is -2. Subtract 3 is 22. Divide by negative is -22. Subtract 3 is 122. Divided by a negative is -122. And then 1/5 subtract 3, what is that? 2 and 4/5. And then divide by a negative equals, divided by -1 is +2 and 4/5. So those are all of the numbers that we would want to plug in for x. So here are all my numbers I'm plugging in for x. 2 and 4/5, 2, -2, -22, and -122. Notice our graph is actually going to negative because your x has a negative coefficient in front of it. That's why we're going to focus more on negative numbers instead of positive numbers. So say we plugged in 2 and 4/5. If we plug that in, we would end up with 1/5 inside our logarithm. And we know log base 5 of, my battery's dying. Log base 5 of 1/5 is -1. So if you plug this in, you would get log base 5 of -1. Of 1/5, which is -1. So this entire logarithm right here is -1, but we have the times 4 in the front, so -1 times 4 is -4. Then you would plug in 2. If we plugged in 2, the inside would equal 1. Log base 5 of 1 is 0. So this entire thing right here would equal 0 times 4 is 0. We plug in -2, we would get 5. So the logarithm part would be equal to 1 because log base 5 of 5 is 1. 4 times 1 is 4. And you're going to start seeing a pattern here. If we plug in -22, we're going to end up with 25. Log base 5 of 25 is 2. So this logarithm part is 2 times 4 is 8. So if you notice on the right side, we have -4, 0, 4, 8. We can predict using the pattern that the next number is going to be 12. Double check our pattern. We plug in -122. 3 minus -122 is 125. Log base 5 of 125 is 3 times 4 is 12. So there's our answer. Now that we have all these numbers, we are going to scale our x and y axes to include all these numbers. Notice that my x values start at 2 and 4/5 and then end at -122. So I need to make sure I have a lot of space on the left side of my x-axis, which you don't have to do on your Khan Academy because they already have it graphed for you. And then my y values start at -4 and they actually increase. So I should have left more space upwards. So I have -4 all the way up to 12. So -4, 4, 8, 12. Cool. And then for my x-axis, I should go from all the way down to -122. So I'm going to do this as -150, -100, -50, and +50. So if I were to graph these points, you just start at 2 4/5, -4. So it's really tiny here. 2, 0. Ooh, even tinier here. -22, 8. Oh, sorry, -2, 4. So tiny here. -22, 8. Tiny here. And then -122, 12. So that's almost to -125. So our graph is going to make this weird curve. It kind of looks like a exponential curve, except it's a logarithmic curve, which is decreasing. Ta-da! There's actually going to be a, what do we call that? Asymptote at 3. X can never be 3 because 5 to the what is going to give you 3 minus 3 is 0. 5 to the, you cannot do that, equals 0. So there's actually a asymptote at x cannot be 3. X cannot equal 3. Ta-da! So that's the graph of our logarithmic function.